design browser history. So for this question, it is asking us to simulate the browser history by implementing the several methods like back, forward, and then visit. So those are the important ones. So the gist of the description is we can visit a website, right? It will become part of our browser history, and we can go back some certain steps of the history and returns the website. And then also we can go forward with our history list. So the one catch for that is when we go back, when we have a history of a list of websites, when we go back and we visit another website again, so it will override the forward history. So what does it mean? For example, like we have four different websites. We currently are on the Leetcode, and then we visit Google, we visit Facebook, and visit YouTube, right? And here we go back one. So we go back one. We're currently at YouTube. We're gonna have Facebook as our current website, right? And then we go back one again. It will be Google. So currently we are visiting Google. So now here is where we go forward one. We're gonna go back to Facebook, and then now we visit LinkedIn. So here is where the override happens. So although we have YouTube as our latest history, because we currently are at Facebook and then we visit another website, LinkedIn, so it will override the history to with YouTube to LinkedIn. So we no longer have YouTube as our latest history anymore, but our latest history will become LinkedIn, and also our current website will also be LinkedIn, right? And besides that, backward and forward, it has a limitation. So when we forward to a point that is already our latest, and even beyond that, and we will return our latest in our history list. The same as backwards, when we go backward, we cannot go backward anymore. So it will return the oldest in our history list. Yep. So by knowing the description, let's think about how do we implement this several methods in this problem. So, and what most important thing is what data structure we're going to use, right, to store the list of history. So consider we have visited 5 websites, so A, B, C, and D, and E, right? And then we go backwards 3 times, and now we're pointing at B in here. And then we visit another one, visit F. So we know in these type of operations, when we go back, for example, 3 steps, we want to be efficiently get what is the current website minus 3 is, right? Sort of need a random accessibility instead of going one by one to check. Going by random access based on index will be the most efficient. So like it will be like 01 time, and there we can get B. Okay. So on the other hand, when we have this, when we visit another site, right, we want to sort of override the existing history with an F, right? But also we should be knowing that if like the current data structure is at the max capacity, we need to add more capacity into our data structure, right? Instead of overriding, we add a new one at the end. So based on what we discussed, the very efficient data structure we can use is array list, because it can provide us the random accessibility based on indexes, right? All right, so let's take a look at the code. So we're gonna store the browser history, a list of URLs, as an array list, and we going to have a current index, which pointing to the current website we are visiting right now, right? And we're gonna have another pointer called latest. So this denotes that what is the latest website in our history. We know the oldest one, the first one in our history will be index 0. But we also need to denote the latest in our history, because we need to know in the case of overriding. So which one is the latest? Because like we know that this one is our current, right? So we also should know what is our latest one at this point, because when we visit F, our latest will be overridden to B rather than C. But we should still have C and D and E in our data structure. We just have our latest history to have a denote that those things are not valid, right? Latest will be actually B in here, right? So we need that because when we go forward, right, we want to bound it within the limitation of our latest history. We don't want to go beyond to this, right? So let's take a look at the how does back and forward being implemented, because they are relatively simpler. So for back, we pass a steps. So all we have to do is to, based on the current, minus how many steps are there. So if it's less than 0, then we bound to our oldest history, which is the index 0, and then we're going to return our URLs based on the current index. Right? This is like a random access to our array list. Similarly, for forward, we're going to plus the steps we needed. And if it's greater than the latest, then we assign latest to our current, right? We want to bound it to our latest history, right? And then after that, we're going to return the urls.get_current. Okay, so back and forward is relatively straightforward. So how about our visit? So for visit, we're gonna have a parameter URL, and here is where we're gonna, like, this is the catch, right? It's a special situation where we are at the maximum capacity of our array list right now. Okay, current is pointing to the last element of the array list, right? So in this case, we are going to add a new element for our history list, and then we're gonna move our current and the latest to the newest element we added, right? Because like currently, our current is the last element of the list, and our latest is also the same as our current, right? Which is the last element of the list. And then we're gonna add a new one, and pointing them both to the new element. So on the other hand, if it's not at the last element of the current list, then which means that the current will be in the middle somewhere. So in this case, like it must be that we went back for some steps and then in our history list. So it could be like went back to B, right? And then now what we're gonna do is we're gonna not adding a new element in our list anymore, but override C, right? When we visit F. So this is where we're gonna increment our current by 1, and then we know we are not at the capacity yet, right? We can set the index of current into the new URL and then update our latest with the current. So that's where we maintain the correct current and then latest pointers. Okay, so once we've done that, then the visit back and then forward are all implemented, and then is able to perform the history search.